In this video, I'm going to go over the 2015 grade 9 math PAT, and parts of this video were also filmed last year, so just make sure you're paying attention to that. Okay, so why don't we go ahead and get started. Okay, so let's get started with this question right here. So with this question, what we're doing is we have a representation of a number, and we can see that we have an exponent or a power on it. So anytime you see that exponent or a power, you want to think what would happen if we took that number and we almost took screenshots of it, is kind of how I like to think about it. So that means we are quadrupling this fraction here. So it's going to be 2 times 2 times 2 times 2 on the top, and that 2 is simply coming from this 4 here. And then the same thing is going to happen on the bottom because the whole fraction is being repeated. So of course the answer to this one is going to be D. Now, one thing I want to point out with a question like this, this would be a perfect question that would actually show up on your part A mental math portion of the PAT, as opposed to it being on part B. But when this PAT was made, there was no differentiation between the two parts. Again, I'm just recording it on Zoom to make it super simple, but let's go ahead and let's go through this one here. So what we need to do is decide where these numbers are going to fall on this number line. So it's going back to really the rational numbers unit. Now, it all depends on how your brain wants to see it. For this one, because we're dealing with some numbers here, I think it's going to be best to convert all these numbers into decimals, and then we can place them on the number line. So -1 3/4. So 3/4, if you remember from one of my videos, I had done the 3/4, like literally 3/4. That's going to be 0.75. The only difference now is we have a whole number, so that's going to change this one into -1.75. So that's what that one's going to be. The next one is going to be 13/8. So we need to think about what's the closest I can get 13 to go into 8 as a decimal. So it's going to be about 1 whole and a little bit left over. So as a decimal with this one, it's going to be 1.625. Okay, and almost always the ones that end in 8 are going to be like that 0.25. Now the other two are going to be a little bit simpler. They are actually just given to us in decimal form. So 1.125 and -0.875. So now we just have to start to order them. So -1 3/4 or -1.75. So if it's negative, of course, I'm going to be looking at the left portion of my number line. So where that's going to fall is it's going to fall here. Now it's not -1, it's a little bit past -1. I don't want to say if it's bigger or smaller, but past -1. So the closest I'm going to get is going to be 0.75. That's going to be really close to 2 if I were to round that up. So the closest I'm going to get is going to be this point here, which is going to be 0.1. The 13/8 or the 1.625, well, that's going to be a positive integer, or positive decimal. So it's going to be sitting on this side of the number line. 1.26, it's a little, 1.6 is a little bit past 1.5. So the closest I can get, 0.5 would be here. So the closest I'm going to get is probably going to be 7 to be 1.6. And then our last one, last couple too, we just have to find where they go. 1.125. Well, that's definitely going to be 1. It's a little bit bigger than 1. It's a little past 1 on the number line. So that's going to be falling with 0.6. And our last one is -8.75. Sorry, clearly I've been doing this for a while today. Our last one is -0.8, which is going to be close to -1, but not quite -1. It's not quite a whole number. So that's going to be best represented by 0.4. So this one is a little tricky because it's building back on linear equations, but let me read it out loud. Aaron buys a cheeseburger for $6.50 and a container of milk for 80 cents. Sam buys a tossed salad and a bowl of soup. The soup costs $2 more than the salad. So I'm actually going to highlight that word here, the more. And of course, we've got our money amounts there that I'm going to keep track of. Sam's meal is less expensive than Aaron's. So that's important because that means whatever Sam pays, it's going to be less. So anytime I hear the word less for something like this, and they haven't told me it actually is a definite amount, your brain should go straight to inequalities. The other hint about going straight to inequalities is we've got our number lines. So before I tackle the question, I do want to make it super clear as to what's going on with those number lines. So anytime we see an open circle, that means we're looking for an inequality that's going to look like this or like this. It's not going to be one of these ones, because that would be like a closed sign indicating the amount could equal that number or greater than or less. Okay, so with the question here, what we've got is we need to figure out a couple of things. So we need to figure out the price of probably the salad. Yeah, sorry, I'm reading the question. We definitely need to figure out the price of the salad. It's telling me that right there. So what I'm gonna do is let X equal the salad. So X will just be our salad. And then we know that the soup costs $2 more. Okay, so anytime I hear the word more, my mind goes right to addition. So $2 more. So I'm going to write the soup, and that's going to be 2 more. So 2 more isn't 2 times, it's an addition of 2 more. So that means the soup is equal to 2 plus X. It's $2 more. Okay, that whole meal is going to be the total amount. So the 6.50 plus the 80 cents. And we know that that's going to be less than the rest of my equation here. Sorry, I'm actually just going to move this down here. So that's going to equal the rest of my equation, which is going to be X plus 2. And you know what? Let me rewrite that to make it more clear. So that's going to be the cost of the soup, which is going to be 2 plus X. And then X, which is the salad. So I'm just basically putting all the variables that I came up with, I'm putting it on the right hand of the equation. And then on the left side of the equation, that just has my cost. So now I can start to combine like terms and solve the same way I would for any inequality or algebraic expression. So if I'm combining this, I have 2 X's and an X. Okay, so that's going to equal 2 plus 2X. And then I can go ahead and combine those numbers there. So I'm just going to go ahead and add it up. And unlike yesterday's exam, you all get to use a calculator. So that's going to be 7.30 is greater than the remainder of our variables. Now we just got to go ahead and solve for X. So to do that, we're going to move all our X's to one side and all our numbers to one side. So it looks like I just have to get rid of this 2 here. So I'm going to add -2 to both sides. That side's going to cancel out, leaving me with $5.30 is greater than 2X. We again just need to figure out that salad. So we're going to divide both sides by 2 because X is being multiplied by 2. And that's going to give me $2.65 is greater than X. Okay. Now, the trickier part though is we got to figure out which number line represents this. So I'm going to show you a trick. And I really hope that this doesn't confuse everyone just because we're so close to that exam. But if we write X on the left-hand side, so X like this, which means I then need to flip my inequality sign. So I'm not dividing by a negative number, I'm just rewriting it. So X is on the left side. And so that means the inequality has to be flipped, right? Regardless, it needs to read that X is less than $2.65 or $2.65 is greater than X. Now what's cool about this, I'm actually just gonna write it up here. Sorry that this is getting messy. Now that I write it with X on the left-hand side, this inequality can actually show me the direction of my number line, providing X is on that left side. So what I mean by that is if I were to draw a line right here, that tells me which way my inequality arrow is going to go. So that means my answer will have to be one of these two. It's got to be either A or D. And I'm looking at A is $2.15. That's not what we got for X, so that's not going to work. So that leaves me with just option D, like that. And so if that trick with the inequality isn't going to work for you, the other way we can also read it is X has to be less than $2.65. Well, if we keep looking through at all of these numbers here, those are all less than $2.65. Okay, and then again, we need an open circle because our inequality was not equal to a number. Okay, so let's take a look at the next one, question number 3. So a question like this looks a lot more daunting than it actually is. So couple of things we got to notice. They gave us the letters P and Q, and all we know is they represent perfect squares that are consecutive. So consecutive means they're numbers that follow one another. So for example, 1, 2 are consecutive numbers, 3, 4 are consecutive numbers. The only thing is we need to look at their perfect square. So I'm going to choose 2 and 3. And when they become perfect squares, we're going to get 4 and 9. So what I'm going to do is I'm going to let P equal 4 and 9 is going to equal Q, or Q equals 9, however you want to say it. And now we just have to evaluate those into the expression. So we're going to go ahead and put 4 plus 9 over 2. Now the whole thing is square rooted, but let's do that at the very well, not the very end, but let's do that towards the end. So 4 plus 9, well, that's going to get me 13, and that's going to be 13 over 2. So altogether, that's going to be 13 over 2. Now, kind of what I've been saying in our previous videos, like that division line or that fraction line is just another way of saying division. So if I have 13 things and I put them into 2 groups, the closest I can get is going to be 6 with 1 remainder. That remainder is going to be split, making it 6.5. Now we have to take the square root of 6.5. You can just plug that in your calculator because this is part B, not part A. And that's going to give us about 2.5. It carries over a little bit, but it's roughly about 2.5. So now we have to go ahead and pop it back onto the number line. So what I'm going to do is just ignore those options there. But what I am going to say is that on this number line, we know P and Q are at the ends. Meaning if I make P 4 here, Q has to be 9 here. Now, when I take the square root of those numbers, that's going to give me 2 on this side and 3 on this side. Perfect. Those are consecutive numbers. So now we have to decide, where does our 2.5 fall? Well, our 2.5 is going to fall right in the middle of 2 and 3. So that means our 2.5 is going to be right there. So our answer is going to be the option where the point that represents this is right in the middle. That option is going to be C. Okay, so let's look at this question here, multiple choice number 4. So before I dive into it, one of the things I do want to let you know is if you are reviewing the exponent laws, or if you need a quick review on it, I just want to put you to this video here where I go through and I break down all the laws that you need to know for grade 9. Okay, so let's look into this question here. What we need to do is figure out how many of the expressions have a value that is larger than 3 to the power of 7. 3 to the power of 7 would be 3 times 3 times 3 times 3, all the way up to 7 times. So that's going to give us a value of 2,187. Or of course, we can leave it as 3 to the power of 7. Figure out which of these options here would amount to that. So let's look at the first one. The first one, we've got a power outside of another power. So for this rule, what we're going to do is just kind of put that in by multiplying the two numbers, right? So we have an exponent outside the bracket. So anytime you do that, you're going to multiply the numbers. So that's going to give us 3 to the power of 8. Now, of course, 3 to the power of 8 is larger than 3 to the power of 7, so that one would work. In our next example, we have 3 to the power of 12, and we're dividing it over 3 to the power of 4. Now remember, when the bases are the same, that means we can subtract the exponents. So that would leave us with 3 to the power of 8. And again, we know that's obviously going to be larger than 3 to the power of 7. All right, this one here is a little tricky. And so what we need to remember is when it comes to adding exponents, it doesn't matter if the bases are the same or not. There's no real exponent law other than just adding the values of the two, right? So for something like this one, we can say 3 to the power of 5 is 243. We're going to add that to 3 to the power of 3. That would be 3 times 3 times 3, which gets us to 27. So if I were to add those together, I'm going to get 270. So that answer is not going to work because we know that if it's 3 to the power of 7, we're looking for this value here. All right, let's keep going. So for this one, we've got almost like a power and another power. So we're just going to go ahead and apply each power accordingly. So that would be 10 times 0. Well, you guys know this, anything to the power of 0 is going to be 0. That's going to be 3 to the power of 0. But then we still need to apply that 2 that's sitting outside of it. So I'm going to go ahead and do that, and then we're going to apply it by multiplying it once more, which will get us again to 3 to the power of 0. Now, remember from exponent laws, anything to the power of 0 will give us 1. So that means the answer to this will be 1. And of course, that is going to be a lot less than 3 to the power of 7. Okay, let's look at our last one here. So our bases are no longer the same. We can see we've got different bases there, but we need to apply the power into it. That's going to be 3 to the power of 6, 2 to the power of 6, and then obviously 2 to the power of 6. So what this looks like is it's going to look something like this. Okay, so now what's interesting about this is I have a number on the top that's the same as the number on the bottom of like that fraction bar. And I always say to remember that fraction bar, think about it as a division bar. So what that means is the two numbers can actually get canceled out, leaving us with 3 to the power of 6. All right, I'm going to use the same strategy for this last one here. We're just going to go ahead and evaluate those numbers. So 3 to the power of 8 is 6,561. And we're going to take away 3 to the power of 4. When I subtract them, I'm going to get 6,480. So of course that expression is going to be larger than 2,187. So that means altogether we've got 3 expressions that are larger than 3 to the power of 7, which makes our answer letter B. Okay, it's multiple choice number 6 here because number 5 isn't being released. I don't think I've seen it being released at all. So with question number 6, we've got Catherine sells cupcakes, and they're using C to denote the amount of cupcakes for $1.50 each. The ingredients for each cupcake cost her 30 cents or $0.3, and the sum of all her other expenses is $20 per month. So when it comes to a question like this, it can seem really confusing as to how to turn these numbers into an equation. So what we have to do is look at the languaging and think about what the languaging represents in terms of math. So a couple of things, of course, we know that she sells the cupcakes, which is C, and she sells them for $1.50 each. So our $1.50 each, anytime you see the word each, it's best to think about multiplying. That means we're definitely going to need to multiply C, the amount of cupcakes, by $1.50. Now the second part of this equation includes the ingredients for the cupcake along with the other expenses. So we've got the $20 per month that she has to pay, okay? And we know that that's going to be a flat rate. So that means whatever we do with the equation, we're going to have to add or subtract that $20. Now we also know the ingredients for each cupcake costs her about 30 cents for every cupcake. So again, if I'm saying per every cupcake or for each cupcake, that means this will also need to be multiplied by C. Okay, so let's think about it. We know we're gonna go 1.50 C because it's for each cupcake, but we also know to make each cupcake, it's gonna cost about 30 cents. So that means this one would be exactly 0.3 cents cupcake. 0.3 cents per cupcake. So anything that doesn't have those two variables, I can cross off right away. So it looks like this one does, but it has 20C. So it looks like this one does, but it does have 20C. And remember, our $20 is like a flat rate per month. So we can definitely take that one out. 1 point for option C, That one does look like it could fit, so we can come back to that. And option B also looks like it's not going to fit. So that leaves us with two options, option A and option C. Well, let's think about what's happening here. For option A, we're saying it costs $1.50 per cupcake, but we need to remove the cost of the ingredients and the $20 flat rate. So to me, that seems really good because that's going to calculate her profit, right? If we look at C, we're saying it's the $20 and the profit, and we're taking away $1.50. Well, we could do it that way. However, that number, the way we write that equation, that most likely might leave us in a negative, right? So if I add this up, I'm going to get 20.3, take away 1.5. See, that's going to leave me as a negative. But we know we need to look at the profits that she's making, where it's costing $1.50 each. So in that case, our correct answer for this one is definitely going to be option A. Number 7 here, and I like this one because it's got my name in it. So basically, Jennifer's goal is to save $1,200 each. $1,200 each week. She saves 20% of her weekly income of $576. So we want to know how many weeks will it take to reach her goal. So let's think about this. We know the goal is $1,200. So this means whatever equation we come up with, it has to equal $1,200. Now let's think about it. She wants to save this much money, but of course she can save more than that much money. If she does, that would totally be fine. We just know that that's her goal. So because she has the potential to save more money than that, we know we're dealing with an inequality here. So that means we can write it like this. We can say it's $1,200, and our goal is to figure out how many weeks. So that means we're looking for a number where she could get to $1,200. So the next thing we need to do is we need to look at the numbers that they gave us with how much she's saving and what her income is. So she's saving 20%, and her income every week is $576. It's $576. So the first thing we need to do with the percent is convert it into a decimal. So if you guys remember, percent means per 100. So that means we're going to take our 20% and divide it by 100. So that's going to look something like this. And that just means we're going to put it in the 100th decimal place. So that will get us to 0.20. Now this question specifically with that percent is playing on some of the content you were supposed to learn in grade 7 and grade 8. Now we need to figure out, well, what's 20% of 576? So I'm going to go ahead and take that decimal, so 0.20, and I'm going to multiply it by 576 to figure out what that 20% is going to be. So when I multiply those together, I'm going to get 115.20. So that's how much money she's setting aside each week. So let's go back to our inequality. She needs to put she needs to save $115.20 for an unknown amount of time or an unknown amount of weeks. So that's what X represents. We have to multiply it by X to figure out how many weeks it's going to take. Now, we just have to solve for X. So that means I'm going to divide both sides by 115.20. And what that does is that's going to cancel out my numbers, leaving me with the value of X. So I'm going to get kind of a wonky number here actually when I go ahead and solve it. I'm going to get 10.41 is less than or equal to X. Now remember, her goal was $1,200. So once I get my value for X, which in this case is 10.4, let's think about this logically. Her income weekly is 576, so she can't save for 10 weeks, 0.4. That means with this value, we actually have to round up. So that means our value for X will be 11 weeks. It's going to take her a total of 11 weeks to reach her goal of $1,200, making our answer for this question, answer B. Okay, so I'm going to take a break from there. Be sure to keep an eye out for part 2 of the video where I finish the exam. Between now and then, if you have any questions or if you need some support, I do hold one-on-one sessions. So all that information can be found right there or in the link in the description. Until then, I wish you all the luck in the world studying, and I can't wait to see you all in the next one.